Welcome to the DIY Honda Garage channel. DTC P0641 Sensor Reference Voltage A malfunction indicates an issue within the Powertrain Control Module, PCM, of the Honda Accord model years 2012 through 2017. This specific diagnostic trouble code means that the PCM has detected an abnormal reading from the reference voltage supplied to the sensors. The PCM is responsible for providing each sensor a stable 5-volt reference voltage essential for their operation. If this voltage drops below 4.5 volts or exceeds 5.2 volts for longer than 2 seconds, the PCM registers a fault, triggering the check engine light to alert the driver. The components involved in this system include the PCM, various sensors, and the voltage monitor, all of which play a crucial role in engine management and performance. Addressing issues pertaining to DTC P0641 is vital for maintaining the proper functionality of the vehicle's engine management system. In conclusion, understanding DTC P0641, which indicates a sensor reference voltage A malfunction, is crucial for Honda Accord owners from model years 2012 to 2017. This diagnostic trouble code points to potential issues related to the voltage supplied to critical sensors, indicating that prompt troubleshooting is necessary. Following systematic steps to diagnose and resolve DTC P0641 ensures that vehicle performance is restored to optimal levels. Further, embracing preventive maintenance practices can significantly mitigate the risk of similar issues occurring in the future. By keeping the vehicle's electronic systems in check, drivers can enhance their driving experiences while ensuring safety and reliability. Thus, awareness and proactive measures form the cornerstone of effective vehicle management, making for a smoother and more dependable ride. The error identified by DTC P0641 involves a malfunction in the sensor reference voltage A system. The Powertrain Control Module, PCM, intricately monitors the reference voltage provided to various sensors, ensuring they receive a stable 5 volts. This voltage is critical for sensors such as the manifold absolute pressure sensor and the fuel rail pressure sensor, among others. When the voltage deviates from the expected range, the PCM detects this irregularity, leading to the activation of a diagnostic trouble code. Continuous monitoring means the system checks for faults constantly, contributing to early detection. Moreover, once a malfunction is identified, the PCM triggers the Malfunction Indicator Lamp, MIL, notifying the driver of potential issues, thereby playing a crucial role in vehicle safety and performance. Several potential causes can lead to the activation of DTC P0641. First, there may be a voltage short circuit to power, which can occur if the voltage supply line to a sensor is compromised, allowing too much voltage to reach it. This can affect sensor functionality and lead to incorrect readings. Conversely, a voltage short to ground may arise, where the sensor's reference voltage is pulled down below the required threshold, resulting in a malfunction as reported by the PCM. Additionally, it is crucial to consider the possibility of a PCM internal circuit failure. Should the PCM itself encounter issues, such as component degradation or damaged circuits, the reference voltage management could fail, thereby setting off this trouble code. Thorough diagnostics are necessary to identify the specific root cause among these possibilities. The primary symptom associated with DTC P0641 is the illumination of the check engine light, CEL. This light serves as an early warning from the vehicle's onboard diagnostic system, alerting the driver to potential issues requiring attention. In addition, some users may notice sensor performance issues. Sensors not receiving the proper reference voltage may produce erratic readings, leading to improper engine management. Other symptoms may include engine misfiring or stalling, particularly if critical sensors, such as the manifold absolute pressure sensor, are affected. The vehicle may exhibit reduced acceleration or odd engine behavior, resulting from incorrect data interpretation by the PCM. It's vital to recognize these symptoms early to prevent further complications and ensure the vehicle operates effectively. The first step in troubleshooting DTC P0641 involves switching the ignition to the on position, ensuring that the vehicle's electronic systems are powered. At this stage, it is critical to utilize a scan tool to check for any diagnostic trouble codes presently stored in the PCM's memory. This process helps confirm the presence of DTC P0641 and aids in recognizing other possible related codes that might provide insight into the underlying issue. Additionally, confirming the code will inform the technician of any potential cascading problems affecting various sensors. By taking note of all active DTCs, a more comprehensive troubleshooting plan can be devised, ensuring an organized approach to diagnosing the electrical system's integrity. Next, it is essential to check the voltage readings at the sensor connections. By using a multimeter, technicians can measure the reference voltage supplied to the sensors, ensuring it is approximately 5 volts as expected. If voltage readings are outside the range of 4.5 to 5.2 volts, this indicates a potential issue with the voltage supply or the sensors themselves. Furthermore, the integrity of the voltage common configuration (VCC) line must be checked to determine if there are any shorts to power or ground, which may affect sensor functionality. Inspecting the wiring harness for physical damage, corrosion, or loose connections is also necessary. This systematic checking will help rule out external factors contributing to the fault denoted by DTC P0641. In the third step, inspecting the connections at the powertrain control module (PCM) is crucial. A secure and clean connection is vital for proper communication between the PCM and the sensors. Technicians should look for any signs of corrosion, dirt, or physical damage that could impede this connection. Corrosion on terminals can introduce resistance, affecting the stability of the reference voltage supplied to the sensors. If any issues are detected, cleaning the terminals or replacing damaged connectors may be necessary. Ensuring robustness in the PCM connections can significantly influence the outcome of the troubleshooting process for DTC P0641 and guarantee a more reliable vehicle operation. After completing the necessary repairs, the final verification step is to clear the DTC P0641 from the PCM's memory. This can generally be done using a scan tool, which resets the error codes stored within the system. Subsequently, it is important to perform a road test to ensure that the vehicle operates normally without triggering the check engine light again. During this period, monitoring sensor operation and performance is essential. Confirming that all sensors are functioning as intended will help validate the effectiveness of the repairs. Successful completion of this step signifies that the DTC P0641 issue has been resolved, thus maintaining the vehicle's reliability and safety. To prevent issues such as DTC P0641 from arising in the future, it is advisable to adopt a proactive maintenance approach. Regularly checking the electrical connections associated with the PCM and sensors is essential. Ensuring that these connections are clean, secure, and free of corrosion can significantly reduce the risk of voltage-related problems. Additionally, periodic inspections of sensors will help identify any degradation or performance issues before they escalate into larger complications. Implementing a preventive maintenance schedule can not only prolong the life of the vehicle's components, but also enhance performance and safety over time. Such an approach saves time and money by avoiding costly repairs and ensures continued reliability on the road. Please like and subscribe to the channel. See you next time.